tutorial we are discussing about use overridden methods to achieve dynamic method dispatch. Let's discuss about dynamic method dispatch. Method overriding is one of the ways in which Java supports runtime polymorphism. Dynamic method dispatch is the mechanism by which a call to an overridden method is resolved at runtime rather than compile time. When an overridden method is called through a superclass reference, Java determines which version, that is superclass or subclass of that method, is to be executed based upon the type of the object being referred to at the time the call occurs. Thus, this determination is made at runtime. At runtime, it depends on the type of the object being referred to, not the type of reference variable. That determines which version of an overridden method will be executed. A superclass reference variable can refer to a subclass object. This is also known as upcasting. Java uses this fact to resolve calls to overridden methods at runtime. Here is a diagram of upcasting. Here superclass object is equals to new subclass, in which superclass is the parent class and subclass extends the superclass. Let's see the advantages of dynamic method dispatch. Dynamic method dispatch allows Java to support overriding of methods, which is central for runtime polymorphism. It allows a class to specify methods that will be common to all of its derivatives, while allowing subclasses to define the specific implementation of some or all of those methods. It also allows subclasses to add its specific methods, subclasses to define the specific implementation of some. Here let's discuss about the conclusion. Therefore, if a superclass contains a method that is overridden by a subclass, then when different types of objects are referred to through a superclass reference variable, different versions of these methods are executed. Let's see the code how we can implement the dynamic method dispatch in Java. Example of using override method to achieve dynamic method dispatch. First of all, we create a class A, and inside the class we take a method void m1 and then print here inside A's m1 method, and then create another class B, which is a child class of A, and override the m1 here and print inside B's m1 method. And again take a class C, which is also a child class of A, and again override the method m1 and write inside C's m1 method. So in the driver class we create a class dispatch, and inside the main method, first of all we create an object of type A, and then object of type B, and then object of type C. Then we take a reference of type A by using A reference. First of all, we put the value of reference is equals to A, and then that is the reference is equals to the object of A, and then call the reference using m1, and then reference equals to B, and then call the reference using m1, and again reference is equals to C and call C version of m1. So what happens here, by calling this reference we can get the method, that is reference.m1. Here the reference is referred to the class A object, so it refers to the method of m1, that is method of class A, and when it becomes B, it is like it dispatch it into the class B object, and hence when we call reference.m1, it calls the method of class B, and when we put the value or we assign the value of reference is equals to C, it means that the reference is assigned to the C object, and ref.m1 call the method of reference of COBS class. So just save it. Let's execute it. So we are already in our location. So just write zavak dispatch.java. Hence it compiles successfully. Let's execute it by writing java dispatch. See, first of all, the A class M1 method call, that is A's M1 method, and then B's M1 method call, and then C M1 method call, because we are calling this method according serially, that is A, B, C. So in this way, dispatching of method or dynamic method dispatch takes place. Thank you.